Welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a fascinating paper published on April 30th, 2025, titled WebThinker, Empowering Large Reasoning Models with Deep Research Capability. So current AI models, especially what the paper calls large reasoning models, or LRMs. These are AIs designed for really complex multi-step thinking, but they often struggle with tasks needing up-to-date or very specific knowledge because their information is static. This paper introduces WebThinker, which is essentially a deep research agent. It helps these large reasoning models by allowing them to autonomously search the web, navigate pages, and even draft research reports when they hit a knowledge gap. It uses a deep web explorer for this dynamic information gathering. Alright, and if you're curious about the inner workings of this WebThinker system and its deep web explorer, the good news is that the authors have shared the code for this work. You can find the WebThinker repository on GitHub. It includes the data, scripts to run the model, and even a demo so you can explore its deep research capabilities for yourself. Okay, so this first figure really gives us a bird's eye view of how WebThinker stacks up against other models. On the left, we see its performance in complex problem solving across several benchmarks, like GPQA, Gaia, WebWalker, and HLE. And in each case, the WebThinker 32B model, which is the one developed in this paper, consistently scores the highest. Then, on the right, we see results for scientific report generation. Here, models are judged on things like comprehensiveness and factuality. And again, WebThinker 32B is performing very well, often leading the pack. One comparison model here is RAGQuinn, where RAG stands for Retrieval Augmented Generation. This is a common technique where the AI first searches for relevant information before generating its answer. Okay, so this next figure, figure 2, gives us a more visual comparison of how WebThinker's approach to using information differs from other methods. We've talked about Retrieval Augmented Generation, or RAG. Well, this figure shows a few flavors. Panel A depicts standard RAG, where the AI does a search, gets results, and then answers. Panel B shows a more advanced RAG, which might do multiple searches and merge results, but it's still a somewhat separate step. Panel C then illustrates WebThinker's process. Here, the reasoning model can think, then decide to use its deep web explorer, get information, think some more, and so on, all in a continuous loop. It's about autonomous tool use within the thinking process, not just before it. Alright, so building on that idea of integrated tool use, Figure 3 lays out the WebThinker framework in more detail. We see its two main operational modes. First, the problem-solving mode, where the reasoning model iteratively thinks, uses the deep web explorer to search or perform a web crawl. That's like automatically clicking links, and then gets information. Second, there's a report generation mode. This mode uses specialized report drafting tools, which can involve another AI, often a large language model, or LLM, an AI, skilled at generating text, to help write, check, and edit comprehensive reports using the gathered web information. Okay, so diving into Table 1, this gives us a more granular look at WebThinker's problem-solving abilities on some really tough benchmarks. We're talking about GPQA, which has PhD-level science questions, Gaia, for general AI assistant tasks, and WebWalker QA, testing web exploration. The table shows pass at 1 foot scores. That's just the percentage of times the model gets the answer correct on its first attempt. And you can see, particularly in the autonomous search within reasoning category, WebThinker 32BRL, which is the version fine-tuned using reinforcement learning, a technique where the AI learns through feedback, consistently achieves top scores, outperforming direct reasoning, and even advanced retrieval augmented generation methods. Now, let's look at Table 2, which focuses specifically on the Humanities Last Exam, or HLE. These are extremely hard reasoning tasks. Again, we're looking at pass at 1 foot scores. You can see different methods, like direct reasoning, retrieval augmented generation workflows, and then the autonomous search within reasoning category, where WebThinker sits. The WebThinker 32BRL model that's the one fine-tuned with reinforcement learning, achieves an average of 15.8. This is a notable improvement over its base version, and even surpasses some other strong models in this very challenging HLE benchmark. Alright, moving on to Figure 4, this one shifts our focus to another key capability, scientific report generation. The table on the left presents results for the GLAIVE benchmark, which assesses performance on general research tasks. You can see WEBTHINKER32BRL. Our reinforcement learning tuned model achieves a really strong average score, particularly in thoroughness and completeness of the reports. Then the plot on the right is a TSNE visualization, which is a clever way to take complex data, like the information an AI gathers, and display it in a 2D chart to see patterns. It's showing content embeddings, essentially numerical fingerprints of the information, and the wider spread for WebThinker suggests it explores a broader information scope compared to other methods. So building on its performance in report generation and complex reasoning, Figure 5 really demonstrates WebThinker's adaptability. This figure shows WebThinker using DeepSeek R1 models, which are different foundational large language models serving as the core engine or backbone at various sizes, 7 billion, 14 billion, and 32 billion parameters. We see comparisons across Gaia, WebWalker QA, HLE, and a report generation task. In each set of bar charts, WebThinker, shown by the purple bars, significantly outperforms both direct generation, where the model just uses its internal knowledge, and standard retrieval augmented generation methods. This advantage holds true as the DeepSeek R1 backbone model size increases. As we've seen across these results, WebThinker consistently demonstrates its power, especially with those larger backbone models. The key takeaway really is how its autonomous search and reasoning framework allows large language models to tackle much more complex research and problem solving. This work is super important for building more capable AI. Well, that's all for this AI Research Roundup. Thanks for joining me. I'm Alex, and I'll see you next time.